I'll start from the problem 57 and the number sums. It says if the 7-digit number x 8 9 4 2 y 4 is divisible by 56, what is the value of x square minus y for the largest value of y, for largest value of y, where x and y are natural numbers, where x and y are belongs to a natural number. Okay, so that means as because this is 7-digit number and divisible by 56, so it has to be divisible by the prime factors of 56. So 56 can be turned into the prime factor of 2 into 2 into 2 into 7 to the 14 or 28 56. Yes, so I can see there are two prime factors, there is 2 and 7, so this has to be divisible by 2 and 7. Now you can see the last digit is 4, so that means it is satisfied, it is divisible by 2. But what is about 7? To a number of that kind, when it is to be divisible by 7, so we can say the rule that the even places odd places number, that means 1 2 3 4, this odd places number minus the even places number, this the odd places up to this, the sum of up to this, leaving the last number, we can say plus 8 9 17 17 21 23 plus 23 minus the double of the last digit, that means 8, has to be divided by 7. So now if I calculate this, plus this is nothing but 15 by plus 7. Now one thing I can conclude that 8 x and y has to be a single digit number, that yourself can decide, because this is a number where no number can be kept as a double digit itself, the place value. Yes, the place value cannot be a double digit, so this x and y has to be a single digit. So from there you can say because this is 15 7, the 2 times is already closed in 15, so the next probably it has to be 3 integer when you divide this number by 7. So x plus y can be 326, so x plus y has to be 6. Now let's see if it is 4. I am going for trial because I am taken 3. So if it is 4, then x plus y is how much? Similarly 7 4 is 28 13. So up to this is okay. If I take the next one, where I am taking 4, now I am taking 5, then how it is? 7 5 is 35 minus, so it has to be 20. But if I take 20, so either of this number has to cross more than 10. If I take x less, so y must cross, or either of both can be 10. So 20 cannot be a legitimate solution for to have x and y of a single digit, so it cannot be a solution. So up to that I can get value. So where 6 and 13, what maximum value of y I can get only here, because that is a possibility, but the sum is also more than the first one. So here the condition is that the value of x is 1 for the largest value of y. The largest value, what it can be, x cannot be 0, so it won't give you any. So x, the minimum value of x will be 1, so y has to be 12. This cannot possible. So if I go to what is the value of a y here? The maximum of y can be 9, because otherwise that would be a double digit number. So 9 I can take here, and then in that case x will be 4. Okay. So in that case the x square minus y square will be the square of this is 16 minus y, so the total value will be 7. Okay, your value of x square minus y has to be 7. Coming to the next problem, 58. What is the smallest number which when increased by 17 becomes exactly divisible by both 520 and 936. So what is the smallest number by which it increased by 17 becomes the exact divisible by this and this? Now if a number is exactly divisible by this and this, then what is the number? So I have to get some number which when increase is divisible by this. So I can get a number which is divisible by this. Then further if I reduce 17 from that, then I can reach to the number, because I want to have some number which when which is increased by 17, I get some number, let's say I get B. So B is both divisible by 520 or 936 or. So this is my equation. Now if I get some number which is divisible by this and this, and now further if I reduce 17 from here, I can reach up to this number where it is needed. Is that okay? Now my first work has to be find some number which is equally divisible by. So if a number is equally divisible by this and this, so it has to be divisible by their LCM. So my first term has to be something, because that needed a smallest number, so it has to be a LCM of this. So if I find the LCM, I could get the number easily. 4, 6, 8, 2, 30, 2, 3, 4, 65, 1, 7, 13, 5, 13 and 9. Yes, 39. So 5. So this is the LCM. So I will get 2 to the 4 to the 8. 8, 5 is 40. 40 into 117. 40 into, if I do something, 8 into 9, if I say 72, and 5 into 65. So I can use the diagonal method to calculate easily. What I do, I will make it in 4 segments. Then I make diagonals 72, 65. So 7, 6, 42, 2, 6 is 12, 2, 5 is 10, 5, 2 is 7, 7, 5 is 35, 5, 2 is 10. So borrow. Now you will add this diagonal wise. So you get 0 here, 5 and 2, 8 here, 3, 2, 1, that means is equal to 6, and 4. So this will be your LCM. So I have got the LCM of this one. So my number would be 17 minus to this. So 4680 minus 17, that will give you 3664. So your answer will be for this is 4663. Okay. Your ultimate answer will be 4663. Okay. Coming to the next 59. What is the largest 4-digit number that are divisible by 10, 15 and 18? So you have to find the largest number which is divisible by this. So I can get some number which is divisible by this by taking the LCM of that, but it has to be a 4-digit number. So let me first calculate the LCM of that, then I will decide what to do next, because I have to find something which is 4-digit. So whether I will getting this directly as a 4-digit number or something less than that. So if I go on doing LCM, I will get something like that: 3, 5, 5, 3, then 5, 1, 1 and 3. So 3 5s are this is 10 and 90. So I am getting 90. So 90 is a 2-digit number. So whereas I have to get 4-digit number. So then the next possible action should be, I know the least 4-digit number and the highest 4-digit number, both. Now my task is to find the highest. So some number which is divisible by 90 must be very near to this highest one or this itself. So I cannot go with that. So my next action should be, I have to try the highest 4-digit number with 90 to divide. Okay. Now if I do it, I find something like that. So I get 9 as an remainder. So the number which has to be perfect multiple of 90 and highest 4-digit has to be less 9 than this. So my number has to be 9999 minus 9. So the answer would be this one. Okay. Next 60, and it will be my last for the number sum. Then after I will move to sums on equation. Okay, the third theory that I have taught: sides, then number, and then equation. Okay, then I will move to the other subjects. Okay, this time maybe I will move to some subject of physics also. So I will come to that. Okay, so my next sum should be, it must be very interesting, otherwise no point of showing you. Yeah, the greatest number that will divide 398, 437 and 5425 leaving 7, 12 and 2 as remainder. Respectively. Okay. Now my question is that the greatest number that will divide this and this, leaving this a different remainder this time. Every time I am getting the same remainder when I will divide the with the greatest number to this. So my action was to find the because I have to have some factor which is common to this, otherwise it cannot be greatest. The common highest common factor, if I find of this, then that would be a number which will be equally divisible to all, which can divide equally to, and that can give you some uh, same remainder. That up to that I have learned that way. But in this case I find that the remainder is also different, so I cannot conclude anything by doing HCF of this number, highest common factor, which will be divisible and give the same remainder. So my pattern was different this time. So the action plan for this is you have to uh, find the uh, the remainder, whatever remainder, the respective remainder has to be subtracted from the numbers. Okay, first you have to subtract the respective remainder from the numbers from which the remainder I am receiving by doing division with the greatest number. So first you have to find 390. I'm getting remainder by this. So yes, 391, and second was 437 minus 7, it is 430, and third one is 5421 5425 minus 7, it give you 54, then how much, 18. Okay, now after getting this, the respective, oh sorry, I have to deduct the respective remainder. It is 12, so I will get something 5, 2, 4. Here I have to deduct 2, so I will get 5, 4, 2, 3. So after getting this, what you have to do, once I got this number, after deducting the remainder, respective remainder, I will end up with 3 numbers. Now I have to find the, as because it has to be a greatest number, in this case also I have to find the HCF of that. So while doing HCF, I am getting this number 391. I have to do prime factorization. For this got 425, and the rest one is 5, 4, 2, 3. Now let's see what number can be divisible. Now either we can do you can find the prime factors of individual and then find the respective matching number, the highest factors, or else there is one other method which will give you the divisional method. So I will go with the divisional because here I can understand the factors, the lower prime factors I will not get. So it will be very tough for the students with the lower class to find such factors. So rather go for the divisional method, will be more easier to find the HCF. So here I will get, so first I will try the lowest number to the middle number. So it will give you 391, and it is 4, 12 minus 9, that is 3. So then further, so I will try this one. So the maximum number I can get is 1 is 34 here, and here is 5, 1, that means 1 again 34. So I will get how much, 17 as remainder, and then I will divide the 34 again. This I suppose you know the division method of factorization, when taking the HCF, so it will be 2, so 34. So the last that I can get some number where there is no remainder remain, then this process will end up. So the first the last divisor that I will get will be the common factor for first these two. Okay, now the same thing I will repeat for the third one, because once I will get 17 as a factor for this, so that must be a factor for this also, then that will be established as a highest common factor, because from first two I already got 70 as a your highest common factor. Now let's try this with 17. So 3, 2, 17, 1, 17, and here it is 5, 1, 3. So 17, 9 if I take, so it will be 153. Okay. Yes. So I will not get any remainder. So remainder will be 0. So it is perfectly divisible. So 17 will be the highest common factor for all these three. So now the greatest number that will be divide ato and ato, so my answer will be, your answer will be 17. Understood? So up to this from for today, and this is the end session for number sums, and later I will come with the sums on equation. Till then, bye.